Hi everyone. So we're getting ready for the Unit 3 test. So our last test of the quarter. Congratulations, we're almost there. So here's the review. Remember, this is found in Canvas. If you just go on the week at a glance, hit the thing called review, and it'll go to the page where it has the review link on there. It doesn't go like straight to the link. It goes to a page that leads you to the link. Anyways, so here we have first question. So I literally wrote this in the way it's going to come out on the test, just as a little helpful hint there. Okay, so if on the first problem you're like, oh my goodness, there's these word problems, I'm going to fail the whole test. Don't be like that. It's okay. It's just 2 problems. It's not that, it's not terrible. Just move on to the next one and then come back to this one later if you want to, right? So here, problem number 1. A builder is designing a rectangular parking lot. She has 300 feet of fencing to enclose the parking lot around 3 sides. All right. So here I like, and on the test there was going to be diagrams, but I just couldn't, I didn't want to make diagrams. It was too hard. So I'm just going to draw it for you. So here's the building. So there's a building just like this. Building. And then right next to it, they're going to build a parking lot. So it's going to be like, boom, boom, boom. We don't know how big it is, right? Does it go over the whole building? I don't know, right? But we do know that the fence altogether is 300 feet. 300 feet of fencing. It's a lot of fencing. So what we're going to do is, well, actually, before we do that, it says number 1, or letter A, define the function a of x for the area. So we're going to do the area of the fence, right? So area of that fenced area. So let's just call this x, okay? Because we don't know what that side is. But if we know that this side is x, we know that the other side is also x, right? Which would make this guy right here would be 300 minus, because the whole thing was 300. Well, if we use x amount for the left part and another x amount for the right part, how much do we have left? Well, we'll just take that out. So it'd be 300 minus 2x. So that's the length of this third side right there. So far, so good? All right, so we're going to find the area. And if you guys remember, the area of any rectangle is length times width. So if you don't know that, remember that. Any rectangle is length times width for the area. So area, so a of x is equal to length, and it honestly doesn't matter which one, but I like using the x as that part, x times 300 minus 2x. That's it. Nothing else to do. That's all you got. Okay, and then what is the area of the fence if a of 40, right? So if x equals 40, what would the area be? So literally, we're just going to plug that in. So a of 40 is equal to, so now here's that x. So we write down 40 times 300 minus 2 times 40, right? So if you notice right here, so here are my x's, that, and so this is my 40, 40, 40. All right, they are all the same. I'm going to boot. So we're using our order of operations here. So we're going to parentheses first. Inside the parentheses, do we subtract or multiply? Multiply. So I'm going to just write it underneath here. So 40 times 300 minus 80, right? So that's going to be, ran out of room here, 400, or 40 times 220, right? And that's going to be a total of 8,800, right? So 8,800, and remember this is in feet, so this is area, so it's feet squared. So inside this fence, right, if we were to get like a 1 by 1 foot by 1 foot tile, we could fit 8,800 of them in there. That's a lot, okay? There we go. So this would be true as, this would be the area if our width right here, if this part right here was equal to 40. Okay, just to give you some context. All right, so letter number 2. Okay, so here's number 2. Let me make this in pink. So the designer is making a poster with a width of 4x and a height of 7x, where x is in feet. Okay, so let me just draw this out. We have a poster here. And this is going to be, oh noise. So we're going to have a 7x as a height and 4x as a width. All right, so far so good. And now it says 2 feet of material needs to be blank on each side. Okay, so whatever it is, 2 feet of this right here, this is 2 feet. Over here, 2 feet, right? This has to be blank. We cannot write in this area at all. because it's not going to be printed out, apparently. They need a better printer. So, and then it says right here, define A of X for the printable area. So the printable area is this white space right here, right? So if we look at that, we're like, okay, so we need to know, let me make this in blue. We need to know this length right here, from here to here. Because we already know the height, that's 7x, that doesn't change. But we need to know that. Well, we know the whole thing is 4x. Well, if it would take out 2 feet from this side and 2 feet from this side, which means what's that left over going to be? 4x minus 4. Remember, because the 2 here and the 2 here. So altogether, that's 4 that we took out, right? So that would be my width. So again, area is length times width. So we're going to go A of X is equal to 7x times 4x minus 4. Okay, that's it. That's the formula. All right, and so what we're going to do now, it says for B, what is the area of the printable part of the poster if A of 3, right? So if X is equal to 3, what would be this? What is that actual area then, if we know what X is, right? So there we go. Where's my mouse? There you are. So we're going to go A of 3 is equal to 7 times 3, 4 times 3 minus 4. Again, wherever I see an X, that's where I'm replacing that with a 3. I'm switching it out. All right, so let's do some order of operations here. Parentheses go first, but I know this is outside the parentheses, and all we need to do is multiply it. I'm just going to multiply it first. All right, and then we go, we'll do multiply first or subtract inside the parentheses. Multiply, order of operations. And then from there, 21 times, this is 21 times 12 minus 4, which is going to be 8. So 12 times 8, which is 96. So that's going to be 96 feet. Yep, we're in feet. So feet squared. This is a really big poster. Not going to lie. That's a really big poster. All right, so that's going to be 96 feet squared. That's the area. So this white area right here is 96 feet squared. If it was 4, or if it was 3, sorry. If that X was equal to 3. All right, so far so good. We're going to keep on going on. All right, this is about the day where my contacts get a little dry. So like, it gets all fuzzy. All right, so a packaging company, so we did this in some of the classes, needs to make boxes. That's what packaging companies do. They make boxes. A large cardboard is 40 inches long by 32 inches wide. Okay, so let's do this in a different color. So we'll do orange. So we have cardboard right here. So always I like to draw them out. For you guys, again, it'll be drawn out for you. This is always helpful for me. So it is 40 by 32. Okay, now it says they cut the same size square from each corner. So it's going to be like same size square corner. You guys have ever tried to make a box, right, with paper? Like it's the same kind of idea, right? You cut it out and then you just you tape those sides back up, the sides back up. So this part is actually not there. So this would be removed, right? And then so remember like this, you don't have to do the sound effects. All right, so there it is. So this will form the bottom and the sides of the box. So like this, right, this big rectangle right here, that's the bottom. And then we're gonna like put up the sides, right? You know, and then we're gonna tape the sides. We're probably not gonna tape it. If it's like packaging company, I'm sure they have a fancy way of doing that. All right, and so what we're gonna do now, it says let X represent the side length of the corner square in inches. Okay, so which means this guy, X. This guy, X. Remember, since it's a square, both sides have to be equivalent or the same. So I'm just going to write all of them as X's. Why not? All right. So it says write the function v of X to represent the volume of a box in terms of X. The volume, right? So remember, think about volume. We're like, oh yeah, I know how to do volume. Let's remember volume. If you don't remember, volume is equal to the length times width, has 3 dimensions, times height. Okay, have that readily available. If you did not know that, or if you forgot that, have that available to you. All right, so what I like to do is I like to just draw a little box here just to help me like imagine like what these dimensions are, because it's kind of hard to tell with this. We call that a net, right? but in geometry, you know, if you took geometry. So here's a new box. And remember, it's an open box because we don't have a lid. We just have the sides for it. There you go. Something like that, right? So the question is, what is this? How high is this box, right? How high is that box? And if you were to imagine in your brain, like close your eyes, imagine in your brain, you're going to lift the sides, right, of this net right here. Remember this part right here and this part right here? That's going to meet up, right? And if you meet that up, that's going to be that height, okay? So that is going to be our x. Oop, I didn't change. That's going to be our x. That's our height, okay? And now what about this part right here? So I'm going to make that blue or aqua. How long is that? Which is going to correspond to this part right here. So how long is that going to be? Well, it's not 32 because the whole thing is 32. So it's going to be less than that because remember, we cut out stuff. Well, how much did we cut out? X and X, right? So if we take those out, what do we have left? Like, well, it was, remember, it was, this was 32. When we take out an X, well, we take out two X's. So it just go minus 2X. If you go minus X times, minus X minus X, that would be minus 2X because you would still combine like terms. All right, so then this would be here, 32 minus 2X. Okay, well, what would the height be then? We'll make that here purple. Okay, so this height right here, or not the height, because it kind of looks like height for me. This width or length or whatever this other dimension is right here, right? What would that be? And if you remember, this is going to be, remember the opposite side is 40, so that means this is also 40. So it's going to be 40, and then we're taking out those x's again. The whole thing is 40, take out an x, take out an x, what do we have left, right? So this is just going to be, this right here is going to be 40 minus 2x. Ah, sorry. Let's see if I can write it. There we go. So this is going to be 40 minus 2x. Okay, so now we got length and width and height. Happy days. So now we can write the volume. So v of x is equal to, right? I like to put in my x first just because that's only, it's a monomial. So it's like a, yeah, so I like to put that first. Even though technically it's my height, it's okay. We're multiplying. It doesn't matter what order we write it in. Let's give me x, parentheses, 32 minus 2x, parentheses, 40 minus 2x, end parentheses. Ta-da! Yay, we're done. Okay, now we're going to evaluate it, okay? Evaluate v of 4 using the function you created in part A, so this guy right here, and explain your answer in context of this problem. So that's part we didn't do above here, so let's explain that. But before, let's first evaluate. So v of 4. Remember, they've already now taken out the x and put in a 4, which means that you're going to have to put a 4 in all the x's. So instead of this x, I'm going to put 4. 32 times, oh, not times, minus 2 times 4, and 40 minus 2 times 4, right? So this is going to equal 4 times 32 minus 8, and 40 minus 8, right? If you want to use your calculator, you can go do that. But at least you got to show me some of the work here, right? And so this is going to be 4 times 24 times 32, which is, help me out here. I don't know. 3,072. So 3,072. Remember, this is going to be in inches, so inches cubed, since it is a volume. Okay, and we're no longer in area. We're in volume, so it's cubic, right? Because literally we did like length times width times height, which is inch times inch times inch, which is inches cubed. All right, and so it says explain the answer in context. So what let's see here. I'm gonna make a little bit more room here. We're gonna go just like that. So I'm gonna just write it up here. Okay, guys, up there. Or for you, maybe it's right there. For me, it's up there. All right, so it's gonna be the volume of the box is what is it, 3,072 inches cubed when the height, remember, because X, it represents the height, right? When the height of the box is, or we said 4 inches. Okay, that's what I would write. Okay, that's the thing. Right, so we wrote that in context. So we talked about the box, we talked about the area, we talked about X, we talked and how that relates to the thing, what we're doing here. So make sure on the test, you explain. If it asks you to explain, you better explain the thing, right? If you're not explaining anything, you didn't answer the question yet. All right, so then we're gonna go on to the next bit right here. This is the last part, the last problem for this kinds of problems. All right, this is gonna be a long video, I can tell right now. So again, if you get this already, fast forward, move on, okay? But I'm gonna just do them all. All right, so a packaging company, okay, this is the same thing, making boxes, right? But this time it's gonna be 50 by 45, okay? And again, they're cutting out squares. So we're just gonna cut out squares like this. And they're not here anymore. We're still calling these X, right? Because it says let X represent the sides, side length. All right. Boop, 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 boop. And it says, okay, on your papers, you guys don't need to write, you don't need to draw it out. Okay, I'm gonna just assume that, unless it helps you. If it helps you, then do it. But here we go. But this is already on the test. So remember, like here, these was our flappy parts. Flappy parts, like Flappy Birds, but not. I'll just assume that's straight. That's just not straight for me. All right, and then again, what is the volume going to be? Right, because remember, if we're going to make our box like this, right? Okay, so what is our height? It's the same. We already know that. It is going to be X. And what is our width? Oh, let's try to make these the same. It's going to represent that part right there, which is going to be, remember, 45 minus 2x, right? Because the whole thing is 45. We're taking out an x from each side, which means we literally took out 2 x's, whatever the x is. We don't know what that is, but whatever it is, we took out 2 of them. Okay, and then our last part right there, when we go back, is this part right here. That's going to represent this part right here. So what is that going to be? Yep. Nope, I didn't change it yet. So that is going to be 50 minus 2x, right? Because we're just taking 2 x's from each side, or 1 x from each side. Okay, so then the volume again is going to be x times 45 minus 2x times 50 minus 2x. Again, if you have not paused yet, and all you've been doing is just watching me do a thing, right? Pause, try it out yourself, okay? Because you're not gonna know if you know how to do it unless you do it yourself. You can watch other people do it. That doesn't mean you know how to do it, right? I could watch people play football. That doesn't mean that I know how to play football. Like, my body doesn't know how to do a thing. I know how to run just a little bit. It's not good. All right, so evaluate. V of 8 using the function we created. Explain your answer in the context of this problem. Okay, so again, we're gonna have to explain our answer. So V of 8, same kind of thing. So we're replacing all the x's with 8s. Where did x go? It got 8. Oh dear. Don't mind me. It's been a long day, peoples. So this is 45 minus 16, 50 minus 16, and that's going to be 45 minus 16, which is going to be, if it was, oh dear, I can't think. So 45, 35, 29. So 29. And then 50 minus 16, which is going to be 34. All right. Let's talk 8. I get 7888. Okay, so this is going to be 7. Oh, actually, I should probably not write it there. Just write it underneath here. 7888. Okay. What did it eat? It ate 8. All right, and so remember this is in inches cubed. And so we're going to write our answer in context. So it says, so when, literally I can just copy this down. The volume, oh, I have a cheat sheet to do it, guys. Okay, so I'm going to go over here, and I'm going to go up here, and I'm going to be like, copy. I'm going to go over here. You guys can't do this on the test because you're not writing on a computer. I'm going to paste that. Oh, shoot. What just happened? What happened to this? See, this is what happens. Okay, forget that. Go back, go back. Okay, let's try it on here. Okay, now I'll bring it over. Oh, phew. Okay, now remember we did not want this part right here because that was part of something else. Okay, now. So we're just going to say the volume of the box is, so instead of this guy, we're going to write down our numbers of 7,888 inches. When the height of the box is, so instead of 4, we're putting in 8. There we go. Done. I did it. Right. That probably took longer than me actually just writing it out. So maybe I should have just written it out. Oh, well. All right. So now we're going to go on to the new stuff, or newer, different kind of stuff. So evaluate functions. Okay. We did this in class, and we just actually did this like 4 times, right? We did it every time we did evaluate v of 8, evaluate v of 4, evaluate a of 3, evaluate a of 40. That's the same thing. Okay. So except a little bit simpler, right? So again, here we have evaluate f of x when this is the function, and when f of x is equal to, or it's f of 3 and f of -5. So we have to do it 2 times. So literally, if you just write down the answer, I'm going to be like, where's your work? I don't know how you got this answer. So please make sure you write down at least this part. So 4, -4, I mean, and then times by 3 to the 3rd power plus 7. Okay. Then you could use your calculator and figure out a thing. But we're going to just move on from there. And so it's going to be -4. 3 to the 3rd power is 27. I normally don't like using calculators that much. And -4 times 27 is going to be 8 to -108 plus 7, which is going to be -101. That's what you would have gotten. All right. And then for -5, you're going to do the exact same thing, except for -5. So remember, always put in parentheses. All right. So -5 to the 3rd power plus 7. So -4 times, remember, this is not -5 times 3. No, it's -5 times -5 times -5. All right, which is going to be -125 plus 7. And that's going to be, I'm going to just put this right over here. So that's going to be 500 positive, right? Because negative times negative is positive, plus 7, which is 507. Yay. All right, and then let's take a look at number 6. All right, same thing here. We have f of -1. So it's going to be 2 times -1 to the 4th power minus 12. My minus are so squiggly. And then we're gonna just evaluate that. Remember, it's -1 to the 4th power, so -1 times -1 times -1 times -1, which is +1, right? So this is actually just 2 times 1 minus 12, right? What's 2 minus 1? Oh, 2 times 1 is 2. So 2 minus 12, that's just -10. Just like that. All right, second one, b is going to be 2 times 4 to the 4th power minus 12. And 4 to the 4th power, I believe, was 256, but let's just check just in case. So to the 4th power. Do you see that? 256, that was right. So 2 times 256 minus 12. So 2 times 256 is 512. So 512 minus 12. Ooh, an easy 500. 500. All right, so we're going to do number 7. Okay, please make sure you don't get messed up with the negatives, okay? Because the negatives always mess people up. So negative of -1, right? That -1 is not part of this negative. This one is this one right here, okay? That's different. And all the people are like, oh, it just cancels out. No, it doesn't just cancel out. all right? And I bet you there's gonna be somebody on the test who does that. Okay, well, this problem's not gonna be on it, but you know what I mean. So -1 to the 6th power, remember, that's gonna be 6 negatives, which means it becomes positive. So that's actually a positive 1, and that negative is right up there. That just gets added on right there. So -1 minus 1, which is, not, I know people want to say 0, but it's not. It is equal to 2. All right, we're going to do the same thing for f of 1, right? So we're going to put that negative from the, oh, I should have changed that color. Very well. All right, so negative, and then there's just 1 to the 6th power minus 1. What's 1 to the 6th power? Again, we're just multiplying 1, so it's just 1. And then that negative, remember, it gets tacked on there because that negative has nothing to do with that 6th power, okay? Nothing. If we wanted it to be together, we would have put parentheses around it, right? But we didn't, so we don't. And then -1, so -1 minus 1. Oh, wait, look, what? It's the same answer. How is that possible? Well, you know why that's possible, because if it's the 6th power, negatives don't really matter because, well, it does matter, it just gets canceled out, okay? All right, so there we go. And then for number 8, ooh, this is gonna be a little bit more tricky. So we have -2, so it's 2, and then -2 to the 5th power minus 3 times -2 plus 5. Okay, and again, if you want to use this on a calculator, you have to show me this part at least, okay? And then you're gonna do stuff on a calculator, but for me, I like to do it in my head. So this is definitely gonna be negative. So it's gonna be negative because that's an odd number. So only these two are negative, these two are negative, that one's, these two are positive, these two are positive, that one's negative. What am I doing? 2, 4, 8, 16, 32. So -32 minus, well, actually it's a plus. Boom. That guy goes over there and makes it a plus. 3 times 2 is 6 plus 5. So this is going to be -64 plus 6 plus 5, which is going to be negative something. Negative 53. Hopefully don't make any mistakes on this because that would be super bad. if I do, if you think I made a mistake, please email me or please send me a text on remind. All right, so we're going to do the same thing with -1. We're almost there, guys, with this part. So f of -1 is going to be 2. Oh, I meant 5. Minus 3 times -1 plus 5. So remember, this is still going to be -1 because -1 to the 5th power. -1 times -1 times -1 times -1 times -1. And then -3 times -1 is going to be plus 3 plus 5. It's going to be literally -2 plus 3 plus 5, which is going to be 6. Yay. All right, moving on. All right, so here we're going to decide whether it's odd, even, or neither. Okay, and remember that you're going to need to write this on your notes somewhere. So remember, if it's odd, right, we're checking. What are we checking? We're checking for rotational symmetry, right? So has rotational symmetry about the origin. Okay, if that is not true, it's not odd. Okay, just because it has an odd exponent, or like one arm is up and one arm is down, does not make that automatically odd. Okay, it has to have this definition of it. And so for an even one, what we're going to do is, what we need to check is, has a, I should say, has the y-axis as a line of symmetry. I'll say that. Has the y-axis as the line of symmetry. And honestly, if you want to see like my wording on there, I wrote down some wordings on the answer part. I don't really remember what they are, but it's something. I'm pretty sure it was pretty good. And if it's neither one of these, then we just call it neither. Okay. So here we go. So if we take a look at this one, we're like, oh, okay, let's first check. Is it odd? So I'm going to put a point right here in the middle and be like, okay, can I rotate it? And literally, if you like go upside down, Or if you're watching this on your phone, they just turn your phone upside down. Unless it does that auto rotate thing, in which case be very careful doing that. Right, you'll notice, oh yeah, it looks exactly the same. So yeah, it does have rotational symmetry. Yes, right? So this one has rotational symmetry, which means that it is odd. So we're gonna say it's odd. It's an odd function because I just do a B, C, right? You can write it all out. Because it has a rotational symmetry about the origin. If you say an answer like, oh, because one arm is up and one arm is down, that doesn't mean that it's odd, okay? Here, if we look at this one, so we're gonna put the dot right here. That's the origin. If we rotate it, is it gonna look exactly the same? Because then that means that this guy up here would be down here on the bottom. Yeah, that doesn't look exactly the same. So it's not odd. Okay, well, what about even? So remember even, we're going to draw that line of symmetry right here on the y-axis. And is the left and the right-hand side the same? Right? Because if you notice right here on the left, that it should be like over here, it should look like this. But it definitely doesn't look like that. So therefore it is not even. So what is it? It is neither. Neither, because it doesn't have a line of symmetry at the y-axis. At the, pretend there's a the there, or nor, is it nor? Neither nor rotational symmetry about the origin. Well, this one is super long, but we're trying to explain why it's neither. Okay, and then we're going to go with this one right here. If you look on the left-hand side, number 11, right? Is it odd? Right, if I put a dot here and if I flip it upside down, it's going to look exactly the same? No, right? Because if you notice right there, right now it's a W, and if we do it upside down, it's going to look like an M. Not the same, okay? And if we draw a line right down here on the y-axis, does the left look like the right? Yeah, it does. Yay! So this is definitely even. Even because the y-axis is the line of symmetry. Reflectional symmetry. I'll just write it like this because that's all I got right now, line of symmetry. All right, look below for my, when you get onto the sheet for my answer. That's better than this one. I just can't think of what I wrote there. That is what it is. All right, if we look at this guy right here, again, we're going to check for odd. If we take this and we turn it upside down, is it exactly the same? Yep, it is. So we're like, yay, it's odd. How odd? Yay for odd things. Right. So odd because it has rotational symmetry. Rotational symmetry. See how it's very much the same kind of wording about the origin. Okie dokies. There we go. Done with those four. Moving on. We're more than halfway there, guys. Yes. All right, we're going to sketch the polynomial. Okay, so there was going to be 3 sketches that we're going to do. And then if you notice right here, we were given roots. A root is at 3, so I'm going to go to 3. And then I'm going to go to 1, mult 2. Okay. So now, do you see how they look exactly the same? The mult 2 doesn't really change that part, but what it's going to change is what the line does at that point. Okay. I would recommend that before the test that you draw, and if you take a long time to draw axes and to draw graphs, then I would like do that before the class starts. Okay. I'm just saying that's going to be a thing. And then I would just like, oh, I have, and then maybe cut it out or something and just put it on. I take a picture. I don't know. just some ideas so that, because if you're one of those people who take a long time making these graphs, this is not where you want to spend your time during the test, okay? Because you don't have time for that, zero time for that. All right, so sketch the following. Okay, we got the roots, multiplicity of 2. A is greater than 0, which means it's positive, because any number that's greater than 0 is positive. Am I positive? Yeah, I'm positive about that. All right, which means, and then also we have a y-intercept at -2. Okay, so now, what in the world does that mean? What does that mean about my arms? Well, technically, we don't even need this A is greater than 0 part, because there's only one way we could do this, but just FYI. So we have right here, there's one root right here, and there's 2 roots here, because remember, 1 multiplicity of 2, 1 times 2 is 2. So then plus the root at 3. So this is 3 roots, which means that we actually have how many degrees? Probably 3. We don't know if we have any imaginary ones, but we have at least 3. So we'll just assume that it's an x to the 3rd power. Okay. So if it's x to the 3rd power, what does that mean? That means it's odd. That means one arm is up and one arm is down. It's one of these. We don't know which way, right? But remember, the A is the number that's in front. So it's in front of this. So if this is a positive number, right? So remember, for the quadratic, right, when it was positive, we said, oh, it opens up. When it's negative, it opens down, right? But that's only because we're squaring things, right? Whenever we square things, it makes everything positive, right? Because negative times negative is positive. But what about for x to the 3rd power, right? If we have a negative number, we have 3 negative numbers, right? Well, if I have a negative times negative times negative, well, that's still going to be negative, right? So this one actually is going to have an arm down first, and then it's going to go up. Because when we do the real, like the end behavior stuff, right? So if it's positive, positive times positive times positive is positive, and that's why the y's are going up, right? And then if it's negative again, that's why the y's are going down, because our answer is going to be negative. All right, so we know it's going to look something like this. So let's try it out. So we go boom. So remember, at 1, it says it has a multiplicity of 2, right? So we're going to, it's going to act just like a quadratic, and it's going to just bounce. We're going to go like boom. And then we got to turn at some point. I don't know when, but we got to turn soon, because we got to go through 3, just like that. Okay. And your graph may look a little bit different, because it might not, it might go a little lower over here, but it's going to look about like this. Okay. And your arm will never be up, because you can even try it. You'd be like, let me just try it. If it's up, I literally can't cross anywhere except for these 2 points at the root. So it would be like, what in the world is that? I don't even know. Yeah, this is not. You're like, we've never seen anything like that. So that's how you know that it's definitely going to have to be down anyways. Okay. All right. So then let's take a look at number 14. We're sketching this guy, roots at 2. 2, 4, and -1, mult 3. Okay, those are some weird points. But anyways, and we have a degree of 5, right? Which means that, and if we notice right here is 1, 2, and then 3, 4, 5. So there, we do have 5 roots. There's a 5th degree, which means it's odd. What this tells us is that whatever the degree is, remember, if it's odd, one arm up, one arm down, right? That's what we're expecting. If it was even, let's say it was a degree of 4, right? Then it would be both arms up or both arms down. Okay, all right, so here we go. And the y-intercept at 1. Okay, we could do that. Cross right there. All right, so how do we do that? Which way are we going to go? And remember, at -1, we're going to have a multiplicity of 3, right? Which means, remember, I would write this on your paper somewhere on your notes. If it has a multiplicity of 2, remember, it acts like a polynomial, right? A parabola. I'm going to just sign like this. So mult 3. Here's going to be my line, mult 4. You're not going to get anything more than that. You might not even have any mults. Okay, well, actually, you probably will. I don't remember, because I don't remember what the test looks like anymore. I forgot. Okay, so mult 2, here's our point, and it's just going to literally just bounce off like that. Going to behave like a parabola. Right, mult 3 is going to behave like a cubic. So we're going to go boom, just like that. And mult 4, remember, the mult 4 looks like a quadratic, except it's flatter on the bottom, right? Because we're doing everything to the 4th power. So it makes those like, ooh, so it's a little bit flatter on the bottom like that. Actually, you don't need those arrows because, ooh, there we go. So just a little bit flatter. That's all. And so that's what we're gonna do. Here we go. So if it's degree of 5, if I try going down like this, okay, because remember, if I go like this, because how do you know which way your arms go? So let's just try. We're gonna go down, we're gonna do a mult 3. So that's gonna be, just clicked it. I'm gonna go down, do this cube, but we're like, wait a minute. How am I gonna get back up to here? I like literally, I can't, right? So we know, okay, then my arms, this is not how my arms are supposed to go. So I'm gonna erase that guy. So let me try from going this way. And we're like, okay, let's go up. We have a cubic, so it's gonna be that little, maybe like that, right? So do you see how that's that inflection point? Try to make it like that. Now we gotta go down, right? And these don't have any mults, so it's just gonna be like this, like this. And if you notice, my arms are like this. That's exactly what I want. Yay, happy days. Okay, that's what it should look like. All righty. And here we have roots are going to be at 1, mult 2. We can't forget that at 1, there's going to be a mult 2. And at -3, ooh, -3 is also going to have a mult 2. What is that about? And then, oh, and then we have one at 0. And then the other thing is that we know that we're going to have a relative max at 3. So I'm just going to, somewhere, we're going to have a peak at 3. I don't know where. We can decide where, but I don't know where. And we know that A is less than 0. Okay, A is less than 0, which means that it has to be negative. But I can't spell negative. All right. So what we do know is that, remember, this is 2 roots right there. Another 2 roots there, so that's 4, and that's 1 root, so that's 5 roots, right? So it's an odd problem, right? So if it's negative, remember when it was positive, right? Because here it was positive, the arms were down, up, right? So now if it's negative, I'm going to go this other way. So my arm is going to be up, and then it's going to go down. Okay, I would maybe write that in. So for negatives, that's what that arms are going to look like. Just saying. All right, so here we go. So we're going to start with our arms up. Arms up. I can't write now. All right. So here we go. Remember -3. -3 is a mult 2, so we're going to go like this. So it's going to be bounce. And then where do we go? We're going to have to cross here at 0. So if I want to have my peak now, I can just do it now. Here's my relative max. Yay, right here. Then it's going to go through 0 because it has no multiplicity. And then, oh, I have to go back to 1, right? But remember, 1 has a mult 2, so it's going to do that little, oh, that's terrible. Yeah, that's kind of better. Oh, good thing I made my max there, right? Because I would not have been able to do it here. So there we go. Just like that. That's what it should have looked like. Okay, and if you look at the answers, it does have something that's similar to that. All right. All right, moving on. 16. Now 16 is different than all the other problems, but this just reading graphs is basically what it is and interpreting it. All right, so here we go. So the function m of x models the attendance at the Children's Museum. I don't know if you ever went to Children's Museum, but it's kind of fun. So if you get older, get married, and go have kids, go to Children's Museum. I didn't even know that was a thing until I became a parent. I missed out on my childhood. All right, so the attendance from the time it opens, which is at 8 a.m., to the time that it closes 10 hours later, whatever time that is, but 10 hours later. All right, at what, so okay, basically what this means before we go into all that. So at this point, at 0, at time 0, we're saying that this is 8 a.m. Okay, which means that, let's say this right here, so at 2, this is going to be 8, 9, and this is going to be 10 a.m. Does that make sense? So that does it work out? So each one of those hours is another, you know, like you could figure out what time it actually is. Okay, so we're going to track that. So now, and this is how they normally do time, just because it's, you know, you don't really want to write 8 a.m., 10 a.m., 11 a.m. So just 0, 1, 2, 3, 4 is way easier. All right, so at what time or times did the Children's Museum have the highest attendance? We're like, oh, the maximum, right here. Boom, easy. Right, if we look at that, oh, that's at 8. That's not 8 o'clock. If you say 8 o'clock, that's wrong, right? Because remember, it's like 10, 11, 12, and then we have to go back to, now it's 1 p.m. 1, 2, 3, 4. So this is my 4 p.m. right here. We're like at 4 p.m. Done. All right. Describe what happened. Sorry, I thought I fixed this. I didn't fix this, darn it. This is 2 P's. Describe what is happening in the interval between 6:63 and 8:120. So here's 6:63, so like right about there, and 8:120, right? So I'm gonna write this up here. So this is my B. So I don't have a lot of room over there. So I'm gonna say, well, what's going on? So remember at 6, that's not 6 p.m. That's actually, well, 2 hours before 4 p.m., which is 2 p.m. So at 2 p.m., let's see here. There are, I should put comma, there are 63 people in the museum. Okay, and it steadily, it increases, or it rises, right? Or attendance increases. Attendance continues to increase, because as you can see, it continues to rise, continues to increase until 4 p.m. because that's where the 8 is. 8 means 4 p.m. So 4 p.m. until 4 p.m. Where there are, is it where there are or when there are? When there are, anyways, 120 people. You can write it better than I can, okay? So where there are or when there are, you can choose whichever one sounds better or is supposed to be better. English people, help me out. Okay, when there are 120 people. Yeah, I've described the interval. I described that it was rising. I talked about the 6 and the 63, the 8 and the 120. There we go, happy days. So for C, what do we do for C? C, it says, identify the zeros in this graph and explain what they mean in the context of this problem. So we have 3 zeros here, right? So 1, 2, 3. So it says to identify the zeros. So there are 3 zeros. So we got to identify them. So let's do that. So it's going to be 0, 0, 3, 0, and 10, 0, right? Remember the y is 0, the x is the number, right? And then from here, what does that mean? So remember that was the beginning of time, beginning of opening. So at 8 a.m., 11, because that was 10, so that's 11 a.m. And so if this is 4, this is 5, this is 6 p.m. So they close at 6. And 6 p.m., there are no people in the museum. See how that goes? There are like literally no people in the museum. So 0, 0, 3. So I've explained the 0, 3, and the 10. That was the times, right? And the 0 for all 3 of them for the y's, I explained what that means, because that means that there are no people in the museum. We're not counting the workers. We're just talking about the attendants, like the people who are in there to be at Children's Museum, right? So maybe at 11, everybody decided to leave and, go to lunch or something like that. I don't know, right? But anyway, you don't know how to explain that part. Just explain what is happening. Okay, there we go. Last 4. Almost done, guys. All right, so let's identify the zeros. Oh, we're just talking about zeros. We gotta now identify zeros. There we go. So here we go. Identify zeros means, remember, what is 0? Y. Y is 0. Why is y 0? That's a whole nother conversation. So again, so this is going to be x times 2x plus 1 squared times x minus 1 is equal to 0. So now, how do we solve for this? Please do not multiply. If you do that, it's going to be sad days, okay? So you're going to remind yourself, 0 product property, okay? So whenever you see something that is factored like this, remember what we do, okay? Because we don't even have a quadratic formula, because this is not even a quadratic. So there's literally no way for us to solve this. We cannot find zeros any other way, okay? Because if you try to, it's going to be so confusing. All right, so remember we set everything equal to 0. So it's going to be x equals to 0. This 2x plus 1, well, that's 0. 2x plus 1 is equal to 0. And remember, we got it twice. So we're going to write it again. 2x plus 1 is equal to 0. And x minus 1 is equal to 0. Just like that. All right, so if the x equals 0 is already solved. I'm going to put the answer up here. So x equals 0. And this is going to be subtract 1 on both sides, right? And so that's going to be -1. And then I'm going to divide both sides by 2. So I'm going to divide that by 2. Sorry, I'll do it again. So again, so this is subtract 1 on both sides. And I got 2x is equal to -1. And then now I'm going to divide both sides by 2. So I get x is equal to -1/2. Well, how many times did that happen? I have one here and had one there, which means it's multiplicity of 2. That's what that means. And then we got the last one right here. We just add 1 to both sides, right? And what do we get? X equal to 1. So 1. Those are the zeros. Okay? Let's try it again. We'll try it 3 more times, actually. So same thing with here. We're going to identify the zeros. So again, we're going to go 3x plus 1 times x minus 2 is equal to 0. That's how we set it up. And now that we know that it's 0, it's equal to 0, now we can say, well, that means that both of these guys can be 0, right? So we're going to set these up equal 3x minus 1 or plus 1 equals 0, and x minus 2 equals 0. Do the math. So subtract 1 on both sides. We've got 3x is equal to -1, right? Divide both sides by 3. We got x is equal to -1/3, or -1/3. All right, same thing with this one. This is, we're going to add 2 to both sides, and it's going to be x is equal to 2. So my answer, x equal to 2, comma, -1/3, or -1/3, comma, 2. It does not matter. Let's go like that. That's it. All right. We're going to keep on going. We got this 2 more times. All right. So we're going to, again, find the zeros. So x times 3x plus 1 times x minus 1 to the 3rd power. So this is going to be x is equals 0. Sorry. So x equals to 0. 3x plus 1 is equal to 0. And this x minus 1 is equal to 0. And how many times are we going to do that? 3 times. Why 3 times? Because it says 3 times. It says to the power of 3. All right. So we're going to solve for this. So this is already solved for. It's just 0. This one, remember, we subtract 1 on both sides. If you have not paused and done this, then just paused and try to do it yourself. You're messing out. I'm going to tell you that one more time. And you would divide by 3. Divide by 3. It's going to be -1/3. Sorry. And this one, remember, we're just adding 1 to both sides, and we get x is equal to 1. Well, we also get x equal to 1 here, and x equals to 1 here. So how many x equals to 1s do we have? We have 3 of them. So what do we call that? 1 molt 3. Ooh, that does not look great. Let me write that one more time. So x is equal to 0, -1/3, and 1 molt 3. There you go, just like that. And if I count, I have 1, 2, and then 3 roots right, or 3, 4, 5 roots right here. So again, 1, 2, 3. But that one, remember, that counts as 3. So 3 of them, 4 and 5. So we have the same number. All right, and my last guy. Let's make it this color. So again, finding the zeros. Set it equal to 0. -2 is equal to 0. So again, since it's equal to 0, the 0 product property says we can set everything, all the factors equal to 0. So x is equal to 0, 5x plus 1 is equal to 0, and x minus 2 is equal to 0. So again, solve for us already. And this is going to be -1, and then 5x is equal to -1. Now we're going to divide by 5. X is equal to -1/5. Then here, let's add 2 to both sides, and x is equal to 2. So my answer is x equal to 0, -1/5, 2. No multiplicities. That's it. So hopefully that was helpful for you. And if you want to go back and review some parts, I would do that. Or just try doing the worksheet right? Just doing the problems and then review it again. Again, if I made any mistakes, please tell me. I'm sorry. My bad. All right. Because I did the review a little bit late. I'm not going to lie. Okay. So I was kind of doing it in a hurry. But anyways, I will see you guys later. Do well on tests. Okay? Bye-bye.